Now, let me explain to you yet another operation in vectors, which is called the cross product or the vector product. First of all, you must understand what a right-handed screw in India does, right? You know what a screw is. This nail, for example, with a spiral, this is the head, this is the tip, and you can hold the head and move it, right? Isn't it? You know this. Pata hai na? Okay. So, for example, if this is the head and that is the tip, and you move it clockwise, it will go into the plane of the mode. If you're always holding the head, and if you move the head and move it anti-clockwise, it will come out of the plane. This is one thing that you must understand. This is large part of vectors, right? The right-handed screw. Hold the head, for example, move it like this, it goes into the plane of the mode, comes out of the plane of the mode, right? Now, if I have two vectors A and B, then A cross B is an operation. A cross B is an operation which produces an output which is a vector C. A cross B is an operation which produces an output which is a vector C. Unlike A dot B that produces an output which is a number, a scalar, A cross B produces an output which is a vector C, which is a vector C. Now, if the output of A cross B is the vector C, then C must have a magnitude, C must have a direction, right? C must have a magnitude, C must have a direction. Okay. Suppose this was the vector A, this was the vector B, right? And the angle between A and B is theta. Suppose the angle between A and B is theta. Then the magnitude of A cross B, that means the magnitude of C. Magnitude of C, which is the magnitude of A cross B, is defined as, because see, these are all synthetic operations, so you're defining all of them. No one can question why is it like this, because that's the way it's defined. There is nothing like why should it be like this, right? This is like magnitude of A into magnitude of B into sine of the angle between A and B. So this will give me the magnitude of the cross product or the vector product of A and B. The cross product has a magnitude given by magnitude of A into magnitude of B into sine theta. So that's the magnitude of the vector C, which is the output of A cross B, which is the output of A cross. Now, there must be a direction of C. There must be a direction for C, right? The direction for C can be obtained as follows. Look, A and B together will make a plane, will lie on a certain plane. Number one, the vector C must be perpendicular to the plane containing A and B. Must be perpendicular to the plane containing A and B. The vector C must be perpendicular to the plane containing A and B. The vector C must be perpendicular to the plane containing A and B. Are you all okay with this? Means this is the plane. For example, it's the plane of the board that contains A and B. The vector C must be perpendicular to the plane of the board. However, C could go into the plane of the board or C could come out of the plane of the board. There are two directions. Despite being perpendicular to the plane of the board, the direction is still ambiguous. It could either dig into the plane of the board or it could dwell out of the plane of the board. Yes or no? Right? two possibilities. Now, the rule of the game is, if it's from A to B, if it's A cross B, at the point where A and B meet, place the tip of the screw, hold the head of the screw, and rotate the screw from A to B. Rotate the screw from A to B. That's a right-handed screw. If you rotate the screw from A to B, realize that it goes into the plane of the board. A cross B. This is a vector C. It would either be into the plane of the board or it would be out of the plane of the board. If you rotate the screw from A to B, the direction in which the screw advances, will give me the direction of the vector. In this case, if I hold the head and rotate the screw from A to B, it will go into the plane of the board. Yes or no? That means in this case, the direction of C is into the plane of the board. The magnitude of C is out of the plane of the board. Magnitude of C is magnitude of A into magnitude of B into sine of the angle between A and B. I'm so sorry. However, if I had A like this, B like this, the vector A like this, the vector B like this is the angle between A and B. Now, in this case, realize that the vector C, A cross B, can be obtained when you rotate the screw from A to B. From A to B, in this case, the screw comes out of the plane of the board. So, the direction of A cross B is out of the plane of the board. Yes or no? Also, come back to this. Magnitude of A cross B is magnitude of A into magnitude of B into sine theta, whereas magnitude of B cross A is going to be magnitude of B into magnitude of A into sine theta. Is that okay? So one thing for sure, magnitude of A cross B is the same as magnitude of B cross A. However, direction. Look, A cross B will go into the plane of the board. You rotate the screw from A to B. But in B cross A, you will have to rotate the screw from B to A. So if you rotate the screw from B to A, it will come out of the plane of the board. Which means A cross B and B cross A, these are two vectors having the same magnitude but opposite directions. Yes or no? A cross B and B cross A are two vectors with the same magnitude but opposite directions. Which means A cross B will be minus of B cross A. A cross B will be minus of B cross A. Always. The vector A cross B will be negative of the vector B cross. They will have the same magnitude, but they would have opposite directions. Does it make sense to all of you? Can I add this off? Same thing. I mean, in this A cross B, what she's saying is could we use the right hand thumb rule? Right hand thumb rule is, the reason I don't talk of the right hand, left hand thumb rules and leg rules is that down the line, especially when you come to magnetism, you will have like umpteen number of rules, one left hand, one right hand, one left thumb, one right thumb, and so on and so forth, and it gets really cumbersome. I remember I was taking my higher secondary exam, and that was one old dilapidated school in South Calcutta, and people from various villages had flocked to appear for the higher secondary exam in that one single huge location. And one gentleman from the village, to find the direction of the current, he was using Fleming's swimming rule, and he actually started doing all this, and he got so badly reprimanded by the invigilator. Swimming rule na korle direction ki kore. Now that guy was so much used to the swimming rule that he had to actually swing his hands and legs, everything all around, to find the direction of the current and the field and so on and so forth. So, I for one prefer to go with that small little nail and do things a little bit here and there rather than throw my hands and legs around to find directions. Alright. But then, if you're still comfortable with that idea and in a miniature manner, you can throw your legs and hands around and handle things without making very vivid descriptions of the same, then it's okay. But then, other than that, best to think of a small little nail and the head of the nail and the tip of the nail, and turn the nail either clockwise or anti-clockwise and imagine whether the nail is advancing into or out. But if you are still comfortable with the hands and the legs rule, I don't have a problem, because there will be so many of them, and by the time we cover all of physics, you will forget which one is left hand and which one is right hand rule. That's the reason I say don't get finicky about what those books write. The thumb rule, although you could have done this, the thumb rule is just because she mentioned, it's like you take your right hand. In order to find the direction of A cross B, take your right hand first. Pledge to do the right thing. Second, curl your fingers. Curl your fingers in a direction so that your fingers curl from A to B. If you are finding the direction of A cross B, curl your fingers from A to B. This is the curl, and observe your thumb if this is the only thumb that you have. Some people have two thumbs. So then it can get confusing for people who have two thumbs. I have had people in my old school with multiple thumbs. So for them, the thumb rule would have become difficult. So then, curl your fingers from A to B and observe your thumb. In this case, the thumb points into the plane of the board. That's the direction of A cross B. If it's A like this and B like this and you have to find A cross B, then curl your fingers from A to B and right hand and observe your thumb. The thumb comes out of the plane of the board. So if you're comfortable with this, I have no problem. Right? This is A cross B. This is A cross B. Right? And yeah, the first vector to the second vector. A to B मतलब अगर if it's like B cross A तब भी A to B लेगा तो उसकी माँ मतलब मार देगा तू. नहीं समझ गया? ये बात नहीं समझा मेरा. तुम B आने आएंगे तुमको हम A to B बोलेंगे तो तुम वही. I told you about this story, right? Out of syllabus story. So long time ago, ages ago, when I was a very small kid, we used to stay in Kakurgachi, and very close to my house was Amidda, and he was appearing for his Madhyamik exams. And every morning I would find, I must have been perhaps in class 3 or 4. Every morning I would find Amidda strolling back and forth with his KC Nag mathematics. Mone koro AB ekta rekha ache, mone koro ABC ekta tribhuj ache, and maga goddamn it. And I used to think, what a serious, sincere student he is. I mean, every day 4 o'clock he would get started with things, and so he went for his Madhyamik maths exam, and I thought he must have done very well. So I asked him, Amidda, kemon holo porikha? Khub kharab holo. Why? What happened? Ki holo? Keno kharab? Bola, sob syllabus er baire. Ami ABC mone kore gechilam, sob PQR chole elo. So then, if I tell him every time from A to B, then even if I write a B cross A, he'll remember only A to B. It's first vector to second vector. Right? A to B नहीं. First vector to second vector. ठीक है? A to B नहीं. जो भी first अगर B है तो from B to A. Right? या यहाँ पे P cross Q हुआ तो he'll still look for A and B. ऐसा नहीं हो जाएगा, हाँ? पाप हो जाएगा. Alright. So, that's a small story of this A cross B, which produces an output, a vector, having a magnitude which is mod A mod B sin theta, and has a direction which you can obtain either by the small screw or you can obtain by the right hand thumb rule, whatever you like, right? Now, obviously, if two vectors are parallel to each other or anti-parallel, say there is a vector A and there is a vector B parallel to A. There is a vector A and there is a vector B and they are parallel to each other. Now, A cross B for these vectors would be 0. Why? Sine 0 is 0. Angle between these two vectors is 0. So the cross product of two parallel or anti-parallel vectors would be the cross product of two parallel vectors or two anti-parallel. Anti-parallel means the angle between them would be 180 degrees. And sine 180 degrees is also 0. So A cross B will be 0 if A and B are either parallel or anti-parallel right? Now, this is the x-axis, this is the y-axis, and the z direction comes out of the plane of the board. The z direction comes out of the plane of the board. This is the z-axis coming out of the plane of the board, alright? A unit vector along the x-axis is I cap, a unit vector along the y-axis is j cap, a unit vector along the z-axis is k cap, right? Now, I cross j, if I have I cross j, I is a vector, j is a vector. If I have I cross j, then this will be a vector c, let's say. This will be a vector, right? Now, magnitude of c is going to be magnitude of I into magnitude of j into sine 90 degrees, because angle between I and j is 90 degrees. So that will give me the magnitude of c, yes or no, right? So that's going to be 1, right? Right? So I cross j gives me a unit vector because magnitude of c is 1. So c is a unit vector, yes or no? C therefore is a unit vector because its magnitude has turned out to be equal to 1. So far so good, right? Now the direction of I cross j, this is I, this is j. They lie in the xy plane, So I cross j should be perpendicular to the xy plane. So must lie in the z direction, because the z direction that's perpendicular to the xy plane is the z direction. So it could either go into the plane of the board, I cross j, or it could come out of the plane of the board, yes or no? Right? Now again, think of a screw, hold its head, rotate the screw from I to j. The screw comes out of the plane of the board, right? So the direction of I cross j is in the positive z direction. Are you still confused about this? So the direction of I cross j is out of the plane of the board in the positive z direction, So that means I cross j for sure is c, which is a unit vector, which we have established, and this c is in the positive z direction, I cross j is in the positive z direction, yes or no? So c therefore is a unit vector in the positive z direction. And a unit vector in the positive z direction is k cap. So I cross j is k cap. Yes or no? So j cross I will be minus k cap. J cross I would be minus k cap. So the moment you reverse the order, there would be an inclusion of a minus sign. Is that okay with everyone? If I cross j is k cap, j cross I would be minus k cap. Similarly, we can establish, see, the way to remember some of these results is put I, j and k on a circle, right? Put I, j and k on a circle in a clockwise order, in a clockwise manner, I and then j followed by k. And then it will turn out that I cross j will be k, and j cross k will be I, see, this cross this will give me this, and then K cross I will give me J. K cross I will give me J. You put I, J, K in a clockwise manner on a circle, then I cross J will give you K, J cross K will give you I, and K cross I will give you J. That is how it turns out to be. And then if you want K cross J, it will be minus I. If you want I cross K, that will be minus J. If you want J cross I, that will be minus K, and so on so forth. Is that okay? So these are a few more results. I cross J is K, J cross K is I, and K cross I is J. Clear? And what's I cross I? 0, because angle between I and I is 0, so sine 0 is 0. Similarly, what's J cross J? What's K cross K? Right? Let me give you just one result without getting into an algebraic mess and without giving you an algebraic proof for the same. Let me just give you one result which you might want to remember in a compact manner. If I have a vector A as ax I cap plus ay j cap plus az k cap, suppose this was a vector, and there was another vector B which was like a bx I cap plus by j cap plus bz k cap. Suppose these were two vectors, ax I cap, etc. Then the vector C, which is A cross B, will be given by the following determinant. I want you to remember this. The first row you write as ijk. The second row you write as ax, ay, az. It's easy to prove, but I'm not getting into that mess right now. bx, by, bz will turn out to be this determinant. A cross B will turn out to be this determinant. The first row is ijk. The second row would be ax, ay, az. The third row would be bx, by. If it was B cross A, then this would be bx, by, bz. This would be ax, ay. Right? And obviously, the expansion of this determinant, as I've already told you, I into ay, bz minus az, by. Then minus j. See, we have plus, minus j into ax, bz minus az, bx. And then plus k ax, by minus ay, bx. Can be, this determinant could be expanded to that form. Clear? You might want to remember this as well. अरे आई कैप वेक्टर है भाई, ए क्रॉस बी का आउटपुट तो वेक्टर होगा ना, फिर आई कैप को 1 डालेगा. आई कैप इज अ वेक्टर, ए क्रॉस बी इज अ वेक्टर whose x component turns out to be this, y component is minus this, z component is this. फिर आई कैप को 1 डालने लगा. घर जाके बार बार अपने आप को शीशे में देख के बोलना, आई कैप 1 नहीं होता, आई कैप 1 नहीं होता, आई कैप 1 नहीं होता. कितनी बार बोलोगे? 100 बार. रिकॉर्ड कर लेना ताकि मेरे को अगली क्लास में सुना सके, बोले 100 बार. ठीक है? आई कैप इज अ वेक्टर whose magnitude is 1. A cross B is a vector. If you put I equal to 1, J equal to 1 and K equal to 1, then this A cross B will turn out to be a number. It has a magnitude which is a number, but its x, y, z components are given by these. This is a vector representation of A cross B. If I have to find the magnitude of A cross B, then I'll take root this square plus this square plus square. That will be the magnitude of A cross B. That is magnitude of A cross B. That is C, the vector C which I wrote. Right? Got me? Confused? No. You understand dot product? At least little bit. Cross product? At least little bit. Right? See, just spend some more time reading these stuff. Not today. I mean, go back home, read the entire stuff back at home. Take a text also. Beginning of our next physics class, ask me questions on that, and I'll address everything. But we'll solve problems now on vectors. I've given you the basic structure of things in vectors, operations in vectors, and so on and so forth. But I want you to get hands-on with some problem solving, basic applications. That's when you'll come to believe that I is not 1, J is not 1, K is not 1. These are vectors, only their magnitudes are numbers. The vectors are not numbers, right?